Out in the vast, empty blue of the Pacific Ocean, there are ghost islands. Perfect, vibrant circles of life that just appear in the middle of nowhere. Miles from any land. For centuries, sailors were baffled by them. These rings of life rise sharply from the crushing depths. Yet their centers cradle calm, shallow lagoons. They look like the rims of giant, water-filled craters. But they were built by the tiniest of animals. These aren't just beautiful oddities. They're the answer to a puzzle that had science stumped for generations. A secret that was finally cracked by a young, ambitious naturalist on the voyage of a lifetime. And what he figured out was that these lost worlds aren't lost at all. They are the living crowns of sunken mountains. The ghosts of ancient volcanoes. Transformed into brilliant oases by a relentless, upward race for sunlight. This is the story of how Darwin solved the riddle of the coral atolls. A theory so audacious, he dreamed it up before he'd even seen one. It's a story of geological forces so slow they're almost invisible. Of life's stubborn drive to survive. And of a scientific mystery that took over 100 years to finally prove. Imagine you're a navigator in the 18th century, sailing across the featureless blue desert of the Pacific. Days, maybe weeks, go by without a sight of land. Then, a lookout screams.
But it's not a towering volcanic peak on the horizon. It's a low, white line of breaking surf.
The perfect circle of churning water in the middle of the deep ocean. As you get closer, you see the surf is crashing against a narrow ring of palm trees and white sand.
And inside that ring?
Not more ocean, but a tranquil lagoon of impossible turquoise. You've just found a coral atoll. These were the enigmatic rings that perplexed the world's greatest minds. They were obviously made of coral. The stony skeletons of tiny marine animals.
They can only survive in shallow, sunlit, warm water.
They depend on microscopic algae living inside them,
which need sunlight to photosynthesize, so they have to stay near the surface.
and that created a massive paradox. When ships took soundings, Dropping weighted lines just off the edge of these atolls, the seafloor plunged for thousands of feet.
So how could a reef built by sun-loving creatures exist in the middle of a deep ocean basin? Where did the foundation come from?
Did the corals somehow build their way up from the dark, freezing abyss?
A journey of miles through crushing pressure? It just seemed impossible.
One popular theory, championed by Darwin's own mentor Charles Lyell, it was that atolls were built on the rims of extinct volcanic craters.
It made a certain kind of sense.
If a volcano rose from the seafloor, but its peak stopped just below the surface,
it would be the perfect shallow platform for corals to colonize. The ring shape of the atoll would just mirror the crater rim.
It was a neat idea, but it relied on an extraordinary coincidence. It meant that countless volcanoes all across the Pacific had to have stopped growing. At exactly the right depth. For a logical mind, that seemed unlikely. Darwin himself would later call it a monstrous hypothesis.
The mystery only deepened when you considered the other types of reefs. You had fringing reefs, which grow right up against the shores of volcanic islands. And you had barrier reefs, which are separated from the island by a wide channel of water.
Fringing reefs, barrier reefs, and atolls. 3 different forms. Were they unrelated? Or was there a secret story that connected them all?
To solve this puzzle would require seeing the world not as a static place,
but as a dynamic stage where even the solid ground of the ocean floor could rise and fall over immense spans of time. Boarded the HMS Beagle for a 5-year trip around the world.
We remember him for his theory of evolution.
But his first great theory, the one that made his name among geologists, was all about these coral reefs.
But by looking at mountains.
As the Beagle sailed down the coast of South America, Darwin became obsessed with the Andes. He found fossilized seashells thousands of feet above sea level.
This was proof that the entire continent was being gradually uplifted over geological time. He even saw it happen himself, when a massive earthquake in Chile instantly lifted the coastline by several feet. Darwin was a huge admirer of Charles Lyell, who argued that the Earth was shaped by slow, steady processes. So if this immense continent was being pushed upwards, Darwin reasoned,
Then, to balance things out, the Earth's crust must be sinking somewhere else.
His gaze turned west, to the vast, mysterious Pacific Ocean. What if the floor of the Pacific wasn't stable, but was, in fact, slowly sinking?
This was a radical thought.
While still on the coast of South America, long before he'd ever seen a true atoll,
Darwin sketched out the core of his theory. Imagine, he thought, a new volcanic island forms, but in a part of the ocean that is slowly subsiding. What would happen?
He hypothesized that corals, needing to stay in the light, would grow around the shores of this new island,
forming a fringing reef.
But as the volcano itself began to slowly sink, maybe just a few millimeters a year, the reef would be locked in an upward race against the descending land.
As long as the sinking was slow enough, the reef could grow vertically,
building on the skeletons of its ancestors.
always keeping its living surface in that sunny, life-giving zone.
As the island kept sinking, the reef would keep growing up. A gap would open between the reef and the shrinking island, a lagoon. The fringing reef had now become a barrier reef.
And finally, Darwin imagined the end of this slow-motion drama. What if the volcano sank completely, disappearing beneath the waves?
The coral, relentless, wouldn't sink with it.
It would stay at the surface, a perfect ring of life, enclosing a lagoon where a mountain's peak used to be.
The atoll. In one breathtaking stroke of intuition, Darwin connected all three reefs into a single, evolutionary story.
They weren't different types, they were just different stages of the same process.
Snapshots in time of a sinking island's long death. And a coral reef's triumphant survival.
In April 1836, the Beagle finally reached the Cocos Islands. Everything he saw, the sheer drop-off into the deep.
The types of coral.
The protective outer wall.
It all fit the theory he had dreamed up years earlier.
He had solved the mystery.
Act I, the birth of an island and a fringing reef.
It all starts in the warm, tropical ocean. Deep in the earth, magma forces its way through the crust,
and an underwater volcano starts to form.
Eruption after eruption, it climbs from the seafloor
Until its peak finally breaks the surface.
A new island is born.
At first, it's just sterile volcanic rock.
But life is always looking for an opening.
Spores and seeds arrive on the wind.
And in the water, microscopic coral larvae drift in on the currents.
They find a foothold on the new island's submerged slopes.
And start building their stony skeletons.
This is the first stage, the fringing reef, growing like a colorful collar right up against the shoreline.
Act 2, the Great Sinking and the Barrier Reef.
Now, the geological clock starts ticking.
The volcano goes dormant.
Its immense weight,
along with the cooling and contracting of the rock beneath it, causes the patch of oceanic crust to slowly sink.
We're talking centimeters per year, a speed that's impossible to see.
for the island, this is the beginning of the end.
But for the reef, it's a call to action.
The corals have to stay in the sunlight,
So they have only one option: grow upwards. They start a vertical race against the sinking island.
constantly building new layers on top of the old.
As the island sinks and the reef grows, a gap opens up between them. Water fills it, creating a lagoon.
The reef is no longer a fringe, but a protective wall.
This is the second stage, the barrier reef. Islands like Bora Bora are perfect examples. A weathered volcanic peak still visible in the center of a gorgeous lagoon, all enclosed by the reef.
Act 3, the vanishing and the atoll. The final act can take millions of years. The sinking is relentless. The volcanic island, once a towering mountain, continues its silent descent.
Until its very last peak slips beneath the waves.
The island is gone.
But the reef, that tenacious engine of life, has won the race. What's left is a ring of coral, encircling a central lagoon where a mountain once stood.
This is the final stage, the atoll.
The atoll is a living monument to this incredible process. Over time, sand and debris broken from the reef can pile up on the ring,
Forming low, sandy islets, the land people can actually live on.
Darwin's theory provided a single, unified story for these three reef types. He saw a dynamic world where islands could disappear, and where life could build memorials on their graves. This story, from a volcanic birth to a ghostly ring of life, is one of the most elegant explanations in all of science. It's a process that builds entire worlds, hidden in plain sight.
We're constantly finding new secrets in our oceans.
Just recently, expeditions have found entirely new species, like a golden tree coral so unique it needed a whole new classification, and pristine deep-sea reefs in the Galapagos that have been thriving for millennia.
The story of our planet is still being written, and the deep ocean holds some of its most exciting chapters.
If you want to join the journey of uncovering them, make sure you subscribe.
There are always more secrets waiting at the bottom of the sea. Darwin published his theory in 1842.
It was compelling, it was elegant, and many scientists loved it. But for all its explanatory power, it was still just a theory.
The problem? Proving it seemed impossible.
To be sure, you'd have to drill straight down through the center of an atoll, through thousands of feet of coral, and see if you hit a volcano at the bottom. The proof, when it came, arrived from the most unlikely of places, the atomic age.
In the mid-20th century, the United States was using remote atolls in the Marshall Islands as nuclear test sites.
And to do that, they needed to understand the geology. For the first time, humanity had the motive and the means to drill. In 1952, a drilling operation began on Eniwetok Atoll.
The drill bit started grinding its way down. The first few hundred feet were just what you'd expect.
Relatively young limestone, made of coral skeletons. As they went deeper, the material got older, more compacted. They passed through 1,000 feet of limestone.
Then 2,000. Then 3.
The fossils in the core samples all showed they were formed in shallow water. This was key. It meant that for millions of years, the top of this structure had always been near the surface, sinking deeper and deeper. "4,000 feet. Still limestone.
The tension must have been incredible. If Darwin was right, they had to hit volcanic rock eventually.
If they didn't, his entire theory was in trouble.
Then, at a depth of 4,154 feet, the drill hit something different.
Something hard.
The cuttings coming up were no longer pale limestone. They were dark. They had found it. They had drilled through over 4,000 feet of shallow water coral. It was the ultimate vindication. It was now proven with cold, hard rock. The ghost islands, truly, were the tombstones of sunken volcanoes.
The discovery at Eniwetok was a massive victory for Darwin's theory.
But you know how science is. The story is never really over. As technology got better, scientists realized the picture was a bit more complicated. In Darwin's time, no one knew that for the last couple of million years,
Earth has gone through cycles where massive ice sheets locked up huge amounts of ocean water, causing global sea levels to drop by 400 feet or more.
Then the ice would melt and the seas would rise again. This constant rising and falling added a powerful new twist to the atoll story. Here's how it works. Imagine an atoll during an ice age, when the sea level is low. The whole reef platform is left high and dry, becoming a big, flat limestone island.
For thousands of years, it rains.
Rainwater is naturally a little acidic, so it starts to dissolve the limestone, especially in the flatter, central part. Now, the Ice Age ends. The glaciers melt, and the sea level rises again, flooding this eroded, bowl-shaped island.
Where do the new corals grow best? On the highest points, that raised rim.
As the sea rose, the corals on the rim grew upwards, keeping pace with the water, while the deeper bowl in the middle became the lagoon.
So, was Darwin wrong?
Absolutely not.
It just means the story has another layer.
Today, geologists see it as a both/and situation. Darwin's subsidence model is the crucial starting point.
You need that sinking volcano to create the thick platform of coral in the first place.
But the final shape of many of today's atolls is heavily sculpted by those more recent Ice Age sea level changes. The volcano provides the deep foundation, but the oscillating sea levels provide the fine-tuning. It's a richer story than Darwin ever could have known.
But one that still has his revolutionary idea right at its heart. From a baffling paradox to a brilliant theory, the story of Darwin's lost worlds is a perfect showcase of science in action.
It started with a simple question.
Why are there perfect circles of life in the middle of the ocean?
It led a young naturalist to imagine a world in slow, constant motion, where mountains could sink,
and life could build monuments on their graves.
Today, these atolls are more than just a geological curiosity.
They are oases of biodiversity and the fragile homes to around 1 million people, with cultures uniquely adapted to life on these tiny slivers of land.
As our planet changes and sea levels rise, these low-lying islands face a deeply uncertain future.
Understanding their past, this incredible story of sinking, growing, and surviving is more critical than ever if we hope to predict what comes next.
They are a living legacy of our planet's deep history.
It's a beautiful secret that Charles Darwin was the first to unlock.